For the entire history of computing, the contract between humans and machines has been entirely one sided. We provide the intent, we provide the instructions, and we provide the momentum. You simply click a button, the software executes a function. If you stop clicking, the software stops working. You are the brain, and the machine is the hands. Think about this. Even with the massive explosion of AI over the last few years, that contract has largely remained the same. You type a prompt into ChatGPT, it generates a response, and then it goes dormant. It waits for you to tell it to what to do next. But today, we are looking at the technology that breaks that contract. We are looking at systems designed to observe a situation, formulate a plan, take action, evaluate the result, and keep going until the object. We are looking at the mechanics of autonomy. And today, let's open up the engine and see exactly how AI agents work. First of all, let's check this out. This is our roadmap. We are going to start with the foundational definitions. So, we are all speaking the same language. From there, we will look at how an agent actually reads a prompt, how it makes decisions, and how it executes tasks in the real world. And then we will end by looking at exactly where this technology is failing and where it is succeeding. Let's start with this. Let's define the terms. What makes an agent different from the chatbot you use on your phone? Think about a task like buying a laptop. If you ask a standard chatbot to find the best laptop under 50,000 rupees, it will synthesize text from its training data and give you a list. If that data is outdated, it doesn't know. If the links are broken, it doesn't care. It generates the text and its job is done. But if you give that exact same goal to an AI agent, the behavior is fundamentally different. The agent does not just generate text, it opens a web browser tool and then it searches Amazon or Flipkart. It reads the HTML of the results page. If the price isn't listed on the first page, it clicks to the second page. It extracts the data, opens a spreadsheet tool and writes the comparison table. It takes in information, it figures out the next step, takes action and it loops back to check its own work. It operates independently until the goal is achieved. You can see the evolution of software architecture right here. On the left, regular software, and it is entirely deterministic. It follows fixed logic. It cannot handle a single typo or unexpected variable. In the middle, basic AI. It handles the unexpected beautifully. It can understand a messy prompt and give a smart response. But it is entirely reactive. Prompt in, response out. And on the right is the agentic workflow. The defining feature here is the loop. Plan, use a tool, act, and then iterate. An agent is not defined by how smart its answers are. An agent is defined by its ability to execute a sequence of actions over time without any human intervention. Now, this autonomy did not appear out of nowhere last year. We have been building toward this for 7 decades. In the 1940s, a field called cybernetics gave the feedback loop. The classic example is a thermostat. It senses the room is cold. It acts by turning on the heater. It senses the room is warm. It acts by turning it off. That simple loop, measure, act, measure again, is the grandparent of every agent we build today. In the 1970s, we built systems like Mycin. It was a medical diagnosis program that used thousands of hard-coded if-then rules to act like a doctor. It was smart but rigid. If a patient presented a symptom outside the rules, the system crashed. And by 2016, DeepMind, this is the company we are talking about, it changed the paradigm with AlphaGo. They stopped writing rules. They let the system play the board game, go against itself millions of times, learning through trial and error. It learned from the environment, and today we have large language models. We took that feedback loop from the thermostat and we placed an LLM in the center of it to act as the measuring engine. The LLM does the thinking, the external tools do the acting. And because agents have been studied for decades, we have a very precise way of evaluating them. In the 1990s, Stuart Russell and Peter Norvig wrote the definitive textbook on AI, and they introduced the PEACE framework. Anytime you build an agent, you have to define four things: performance, environment, actuators, and sensors. Let's use a self-driving car for example. Performance. How do we measure success here? For the car, it is getting to the destination without crashing and within a reasonable time frame. Next up, environment. What are the physical constraints? The road, the weather, pedestrians. Let's talk about sensors. How does it see the environment? We can use cameras, radar, GPS. And when it comes to the actuators, how does it impact the environment? It impacts the environment by using the steering wheels, brakes, and accelerator. Whether you are building a digital agent to manage your inbox or a physical agent to drive a truck, you define the system using these four parameters. Inside the system itself, an agent relies on four physical structures. Think of it anatomically. Perception is the eyes and ears. This is how data gets in, usually through an API or a user prompt. And next, memory. It is the storage. It needs short-term memory to remember what you asked 5 minutes ago, and long-term memory to access company databases. And next up is reasoning. It is the brain. This is the LLM evaluating the data and deciding what to do. And next up, action. It is the hands. This is the execution phase. When the agent uses a tool to change something in the outside world. If you remove the tools, it's just a chatbot. If you remove the memory, it forgets the plan halfway through. All four must function together.